Okay, let's try that again. Not only do you need to practice this formula because sometimes you can't do the easier method, it's just good practice. Good practice. All right, I just want to show you something. This particular function, if I was trying to do the most, expedient, the quickest method, I actually would have chosen to solve this by factoring. Because if it can be factored, it's usually quicker. All right, I'm gonna get to where I want to go easier and faster when that's the case. So just like normal, x and x, and I had to think about these factors. If you don't know your multiplication facts so well, you might want to do the quadratic formula. But if you do have a good grasp of your multiplication facts, eventually you'd figure out that 8 times 5 gives you 40, but I would have to make it a positive 8 and a negative 5 for that to equal negative 40 and to add to positive 3. And so just there, we could have done, set it equal to 0, but that's going to end up changing signs. So that's going to be x equals negative 8 and x equals positive 5 because you set each one equal to 0, solve for each one. And look how easy this was when I solved it by factoring. It's like 2 steps versus dun, 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 dun. I mean, that's a whole lot easier. But sometimes I'll give you problems where you can't just simply factor it, so that's where the benefit of that is. Okay? So, it's time to move on to a new fact, all right? And that topic, and I need you to take notes. I mean, it's not like class is over just because we're not together. Get out your notebook right now. Pause the video if you need to. Get out your notebook. And I want you to write down, you ready for this? This is a new word. It's not discriminate. It's discriminant. Can you see that? Discriminant. I think I spelled that right. It might be discriminate. Nope, discriminant. All right, it's a weird word. Check me on that. But that word describes the inside portion of your quadratic formula. So for example, you had, where is it? Your quadratic formula. So you have all this, negative b plus or minus square root. The discriminant is that part right there, all right? So if you want to go back to your original quadratic formula and just write that word in there, discriminant, boom, that's what the discriminant is. And the discriminant has only really one purpose. It tells me how many solutions and also I would add what kind of solutions, all right? That's as good as my handwriting gets, all right? So sorry about it. How many solutions and what kind of solutions? For example, and this is going to look kind of funny, but bear with me as I spell this out. Whenever my discriminant, that's the b squared minus 4ac. If I were to plug the b, the a, and c into this part, and I get a number that equals something greater than 0, like a positive number, when b squared minus 4ac is greater than 0, that means it ends up equaling a positive number, like 12 or 15 or anything that's not negative or 0. Whenever that discriminant number equals something more than 0, that you're always going to have 2 real solutions. 2 real solutions, okay? So like, for example, let's look at what we just got done looking at. We did the b squared minus 4ac portion, right? This part right here, it ended up equaling this number here, 169. That doesn't say negative 169. That doesn't say 0. It is a positive number. It's more than 0. So that ended up equaling 2 real solutions. You got 5 and negative 8. See how you have 2 solutions? It doesn't tell you necessarily what the solutions are. It just lets you know eventually you're going to have 2 real solutions. So look, we got 2 real solutions. The discriminant let us know that. Okay, with that fact, when this is a positive number, in other words, you'll always have 2 real solutions. If b squared minus 4ac, this part right here, if that equals 0 on the nose, all right, if it actually equals 0, if you got, if you're doing the quadratic formula and eventually you got your discriminant equals 0 underneath it, you're always going to have 1 real solution. 1 real excuse me, solution. And lastly, of course, sometimes b squared minus 4ac will be less than, ooh, that's ugly, less than 0, okay? That means it's a negative number, like negative 11. That would be a negative discriminant that's less than 0. Like negative, I don't know, 63, okay? Whenever that is a negative number underneath that radical, okay, the answer is 2 imaginary. And I know that seems weird, but it's actually a thing. Imaginary solutions. You can actually have in math real solutions and non-real solutions, which sounds scarier than it really is, guys. It really is. And I'll show you an example. So let's take a look at this problem. I already pre-worked this so we could expedite this video and get the understanding to occur. And this was the original problem. See how it said equal to negative 10? Well, I had to add 10. I'll do it for you right now. I had to add 10 from this side back over here in order to make it look the right way, okay? Negative 8 plus 10 is 2. So now that equals 0. See what I did there? See what I did? It's not too bad. And then I try to use the quadratic formula. Negative b. Now watch this. That b is negative itself. It's a negative 3. So the formula is also negative b. So I had to do negative 3. See that? It's a little trick. So negative b plus or minus the square root of b squared minus 4ac. You see that? Now I worked this out. I looked inside the discriminant, the b squared minus 4ac. I worked it out. And eventually, boom! Take a look at this discriminant. Is that more than 0? Negative 63. Is that number more than 0? No, it's not. I know, it's not. Is it equal to 0? Well, no, Mr. Morris. I know. It's less than 0. It falls under this window. B squared minus 4 is less than 0. Guess what? Anything that's negative, anytime your discriminant is negative, that's less than 0. And technically speaking, you can't take the square root of a negative number. Not going to happen. Can't do it. Why, Mr. Morris? Well, because there's no number that you can multiply by itself that will ever equal a negative number. That's what a square root is. So like, for example, 3 times 3 equals 9, right? Doesn't equal negative 9, it equals positive 9. Well, what's negative 3 times negative 3? Oh, that's also equal to 9, positive 9. See, negative times itself is still equal to a positive. A positive times itself is still equal to a positive. There's no way you can multiply any negative number times itself and equal another negative number. It'll always equal positive. So this is technically an impossibility. So in math, for some reason, they came up with this concept. Whenever that happens to happen in the quadratic formula, we denote that it's an imaginary solution. It's not real by this I symbol. And so that is literally how you'd have to leave your answer. Can't do anything else, all right? The square root of an imaginary 63, if that makes sense. Okay, so this means non-real solutions. There's 2 of them, so that's why that is. Okay, so for your homework that I'll be posting, you're going to solve some quadratic formula, but you're also going to do some where, how do I word this? You literally just do the discriminant, and you find out, is it positive, equal to 0, or less than 0? And then you're going to tell me how many solutions it has and what kind. Is it 2 real solutions? Is it 1 real solution? Or are there 2 imaginary solutions based on what you get? Are y'all with me? Email me if you have questions or call me. Okay? That is what we are going to be practicing. All right. Have a blessed day. Stay safe and healthy.